Okay, in 8.4 we were working with density, and the way we use density is actually to help us find the total quantity of something, whether it be a population or a mass or something along those lines. But the way you compute total quantity is you take density and you multiply it by the space available. So in this example, it says a rod length of 3 meters has a density d of x equal to 1 plus x squared grams per meter, where x is the distance from the left edge of the rod. Set up a definite integral and compute the total mass of the rod. And so this one's actually a fairly straightforward example. So if you had this 3-meter rod, the mass at some point, let's call that delta x, the mass at that space would simply be the density at that space. Well, the density at that space is however far it is from the left, or 1 plus x squared. So that's our density times the space available. Well, the space available is just how wide that strip is, delta x. So essentially, we're just going to do a definite integral from 0 to 3 of 1 plus x squared dx. And that's a fairly simple definite integral. We should be able to do that one by hand. The antiderivative of 1 is x. The general antiderivative of x squared is 1 over 3x cubed. And we're doing that from 0 to 3. So 3 plus 1 over 3 times 3 cubed minus 0 plus 1 over 3 times 0 cubed. And on this side, we'll get 12 minus 0, which is 12. And since we're talking about mass, we should certainly include the units here. Our units, if we're talking about mass, in this case is grams. These circular examples, we've done quite a few of these. And so I'll try and break down again what's happening in these examples. But it says circular city is densely populated at the center, but thins out near the city limits or out toward the city limits. A couple typos in there. Its population density can be measured as a function of the distance in miles from the center R, where density is 10,000 times 4 minus R people per square mile. So that's our density function. Assuming that the city limits are at a place where the population density is 0, what is the radius of the city? In other words, when does density go to 0? Well, if I solve that, 10,000 times 4 minus R, when will that be 0? And obviously, if R equals 4, that would give us 0 for that function. So in other words, if R equals 4, the radius of the city is 4 miles. Okay, compute the total population of circular city. Make sure you know the area of a strip and the density of a strip. So this is going to be a really important thing I may ask you about. To make sure you really understand what's happening, I want you to understand those parts. So let's just kind of draw a picture of what's happening. Here's our city. And what we're going to do is we're going to slice this city up into strips. So in this general area, and I'm going to make that strip as narrow as I could possibly imagine. So I'm going to say that strip is delta R wide. All right. Well, we know that the total population of a strip is its area times density. So let's first find the area of a strip. If I took this strip and I unrolled it, it would actually form a rectangle, where this would be delta R And the length of that rectangle would be the same thing as the circumference, or its distance around. We know distance around a circle or circumference is 2 pi r. So the area of a strip is 2 pi r times delta r. The population of a strip, or the density of a strip, the density of the strip is 10,000 times 4 minus r. The population of an individual strip would be the density times the area of the strip, or 10,000 times 4 minus r times the area of the strip, 2 pi r delta r. And if I wanted to simplify that population for just one strip, you would get 80,000 r minus 20,000 r squared times pi times delta r. And all I'm doing there is I'm just simplifying that. That is our population. That's our population of one strip. But we want to find the population of the whole city, so we need to add all of these strips up. So we're going to take this formula, pi times our radius goes from 0 to 4 of 80,000 r minus 20,000 r squared dr. And again, don't forget to multiply by pi at the end. But if you use your calculator and compute this and then multiply it by the pi, you'll get 669,867. I'm going to round to the nearest person because we're talking about people. So that, in other words, we're saying there's 669,867 people in this city. But again, I really want to make sure you understand these important parts. I want you to understand this area of a strip, and I want you to understand this population of a strip and how to come up with those two numbers and make sure you can distinguish between them, what those things really mean.